In this video, we are going to continue where we left off. In the previous part 1, 2, and 3 videos in the binary classification machine learning project using bank marketing dataset, we have already gone through the several steps, including importing necessary libraries and modules first. Then we have loaded the dataset, and we had hands-on data overview, including understanding shape of the data, looking at the first few rows of the dataset, understanding the information about the data, and some statistical description of the dataset. Then we worked through on cleaning the column values, column names, and we have also checked the target variable distribution. Also, we did some missing value check, along with checking if we have any duplicate values in any of the columns in the dataset, which happened to that we have not found any duplicate. Along with that, we have done some numerical and categorical column separations for our dataset so that we can do enhanced analytics and exploratory data analysis. Plus, we can process the data extensively for machine learning models. So now the next step is going to be exploratory data analysis. And here, this is going to be a gigantic walkthrough. I'm going to walk you through on those visualization, not diving line by line on the code. However, I'm going to make sure that you understand what is the findings of those exploratory data analysis. And that includes understanding the target variable distribution, numerical feature distribution, outliers, categorical feature counts, checking unknown values in categorical columns, relationship between numerical and categorical features, and the target variables, understanding the correlation between the numerical columns, and then few business-friendly comparison charts as well. So basically, EDA is not only about going through and creating the plots. It is about understanding your data before beginning machine learning models. So that being said, let's straight dive into that. First of all, let's begin with having idea of how many numerical features we have, how many categorical features we have. Also, let's have the target variable separated already. Now, as we already see here, that our target feature is Y, target column in the dataset, and we have 7 numerical features. These are the columns here, 9 categorical features. These are the column names or categorical column names here. So after we do that, what we are going to do is understand the target variable distribution, which we have sort of already understood in the previous video. If we quickly want to have a look at our target variable distribution, what we want to do is we want to group by the target feature and do the value counts and create the target summary, plus also create the value for the percentage. And then we want to display that value in the tabular structure, and we will have a quick visualization to understand those distribution. If you need to pause the video and have a look at on the code real quick, please feel free to do so. It is really important that you have some understanding of the coding side as well when you are building machine learning projects. Here we understand that there are 39,922 categories of no on our target variable, means customers did not subscribe for the campaign. And here we have 5,289 yes, which leads to be 11.7% being yes, and then 88.3% to be no. So we have a huge imbalance of the data set that you can see here in our target distribution count. No is the most of the records in the data set. Yes are just a few, just above 5,000 records, and which we have already seen here on 88.3% being no and 11.7% being yes. What we have learned from this is we have a huge imbalance of the target variable. So we have a binary classification problem, and even on the binary classification problem, most of the records are no or labeled 0 that we are going to consider, and some of the records, only 11.7%, are yes. Earlier, we had created the numerical features section already. So on our previous analysis, we have created the numerical feature columns, and we have also created the categorical feature columns. Those we are going to utilize and do individual analyses. beginning with numerical feature summary, we're going to look at the mean, median, standard deviation, minimum, maximum, and skewness along with the count. So to do that, we are performing the statistical summary. So that is df numerical column dot azz, that stands for aggregate, by count, mean, median, standard deviation, minimum, and maximum. We're going to transpose rows to columns and columns to rows. Then here we are also building the skewness as well to understand those distribution, if we have a right skewness, left skewness, or normal distribution. Then we are going to print the statistical summary of our numerical features. So if I run that, here we can see that count column, mean, median, standard deviation, minimum, maximum, skewness. And you can see here there are most of the values, or almost all the columns have the right skewness. Right side we have a large values. And then that means we have a larger values towards the right side, means there are just a few records with extremely high balance, and we have previous and p days as well. So that's how our data set look like. We can visually see the data and build better understanding. So we are going to use the histogram with the KDE plot for our numerical features. That will help us to build better understanding about the data. Let's do that. So I'm writing a for loop to go through all numerical columns and create a histogram with the KDE line that will help us to understand how does exactly the distribution look like. And I want to set that up, the bins, to be 40 bins, and these are labels and titles of the visualization. If I run that, I'm going to get all of those histogram for all the numerical features using the for loop. So beginning with age, you can see that there are just a few customers with age close to 90 years. And there are just a few customers after the age of 60, which tells us that most of our customers fall under the age of somewhere from 25 around at 60. And we have just a few also customers with maybe 45-ish age. And likewise, here we have a huge long tail of the balance on our data set. Looks like there are just a few customers with very extremely high account balance in their account, and most of the customers fall under 20,000, maybe under 10,000 only. So most of those customers are close to zero balance. And here we have distribution of day almost everywhere, and also the duration. Here there are just a few customers with extremely high duration, and most of the customers fall under 1,000 duration value. Same way, campaign, extremely outlier values, P days, extreme outlier values as well. And here, this is the worst. Duration of the previous, that is extremely long tail. Maybe we have just one or two records towards 250 or 200. That's why we have this long side of the value showing up here. So the key finding, as we understood already from the visualization, is that the values are extremely skewed towards the right side. That means we have extremely high outlier values, and towards the right side, that means just a few records with extremely high values on those numerical columns. We can also look at the same thing using the box plot for the outlier view. I'll run a for loop on our all numerical columns, and I'll plot a box plot, then title, labels, and showing up the box plot. Here by age, some outlier values, balance, some of those customers, around 10-15 customers with extremely high balance, and most of the customers are not with the very high balance in their account. So day doesn't have much outlier or any outlier. Here the duration, same way, some outliers, campaign, some outliers, P days, extremely outlier values, and there are most of the records fall on this side. Previous, of course, just one value above 250, rest of those sit around 50-ish. So that says that previous only one value has extreme high outlier. If we happen to remove that value, this box plot would look extremely different than what we are seeing right now with the outlier values. Now, as the key findings that we have seen a lot of almost all the numerical columns with extreme outliers except just a few. Now, if we have those box plot separated by target, how does the distribution look like for yes and no? So I will run the for loop on numerical columns, and here I will create a box plot, that to be data, the target column, y to be the column that I want to go through, that is numerical column. That will create the two box plot line. One is going to be no, one is going to be yes. And that's where I can see that if the target label or subscribe to the term deposit was no, how does the age distribution look like of those customer not subscribing for the term deposit? And how does the distribution of the age look like for those customer who subscribe for the term deposit? That's how we can see for each individual numerical columns using this for loop. So same way, there is no much identifiable pattern on the age. But by the target class, look at this here. There are some identifiable pattern. Here, some outlier towards the lower value and some customers with negative balance. And they have not subscribed to the term deposit, of course, as understandable. And here we have extremely high balance, which the customer have not subscribed as well. So day by the target class, not much identifiable pattern there. And here, duration by the target class, so no has some extreme values, but those are not significant enough to understand, hey, they are the most impactful features. And here, by target class, almost similar pattern, slight different, and that is not significantly impactful to say this has definite some impact on it. So here, we can see that by the P days, by target class. So customers not subscribing for the term deposit, the P days are extremely low, that have most of the customer that have the P days to be extremely low have not subscribed. And here on the yes, most of the customers that have subscribed to the term deposit, P days are around maybe close to 100, and some of those customers have extremely high P days that have subscribed to the term deposit. And here in this case, so previous, as we have seen before, that 250 extreme outlier sits for the customer who has not subscribed for the term deposit. Saying this way, it helps us to understand how does the distribution look like if we separate the target values or separate the visualization using the two different target label, yes and no. And as we have already seen that, there are some patterns on that, but not extremely decisive patterns. So if you look at, again, mean and median comparison against the numerical features and targets, which we have done so far on the visualization, let's look at the mean and median. That will help us to understand how much impact we have if we look at the mean and median by the outlier. And that will help us to understand, look at this age here, those customers who's not subscribed 40, subscribed 41, not huge difference. However, if you look at this balance, so customers, those have subscribed for the term deposit, the average balance is 1804, not subscribed 1300. So slight difference there. And you can see likewise here 221, 537, and here we can also see the difference previous 0.5, 1.17, etc. If you look at the median value, those don't look huge difference except few columns. Here, the balance median for those customers who have subscribed is 732, not subscribed 417. But here, if you look at some of those features, there are some difference as well, but the day is close to each other, not so much difference for both the labels. So this will give us the good understanding of the data. What should we do for the outlier value or any other issues in the data set? So same way, we can build understanding on our categorical features as well. If you remember, a list of categorical columns created. From there, we can create the unique categories by calling df each columns dot any unique. And we can also create the most frequent category, which is the category that repeats the most frequently and with how many of the time it has repeated. That count also we can get, and that will be the tabular representation. So we want to create the count and the percentage of those most frequent category, and we will display that as the summary table. So here we can see that column job has the blue collar job most frequent category, that is 9,732, and we have 12 categories there. Month, 12 categories. May is the most frequent record. Same way we can look at all of those count and the percentage of the most frequent categories, and we can also look at the unique categories on each of those columns. Continuing to build the understanding on the categorical features, we can use the count plots. And by that count plot, we'll be able to see how many of the counts of each categories look like in each of those columns. For example, here, I'm running a for loop on all of those categorical columns. I'm plotting and I'm building the count plot from the value counts. And here I'm just giving the label, title, etc. So if I run that, now I can see all of those categorical columns and their value counts or unique counts of the each categories of those columns, including job category. Most of the records in our data set is for blue collar job, and those are close to 1,000, 10,000, and here management, technician, admin, services, retired, and most of those, most less frequency is for unknown and those student, housemaid, etc. Same way for the marital status, most of our customers in our data set are married and just a few are close to just above 5,000 are divorced. Education, same way, unknown, there are some missing education information, and most of the customers that we have in our data set have the secondary level education default. So most of the customers in our data set are not in the default, maybe loan default or credit card default or bill payment default, something like that. But some of the customers, yes, in our data set have fallen into default category, and the same way for the housing. And here we have also loan being no, most of the customers in our data set do not have a loan in the bank, and some of the customers do have the loan. Here, the contact, cellular, telephone, and unknown. So most of the customers use cellular phone as their primary contact. Same way for the month, we have most of the customers in our data set have a May month value, and then December is the least records that we have in our data. So P outcome, so here unknown, most of the data set for our P outcome is unknown, and failure, other, success have just a few records. Same way, we have seen there are some unknowns in our data set, which columns have unknown value, and we can do something about it. We can make that as a missing value because that's not a valid information. I want to go each categorical column, find out that unknown, and count and create the summation of the counts. I want to also find out the percentage, how many of the records in each categorical column have unknown values. And I want to have that count and the percentage as well by the column. And I want to build a table that gives us that analysis. So P outcome, unknown count is 36,000, and that is 81%. Almost all the records are unknown. Contact 28%, education 4%, and most these columns do not have any unknown values. So we can plot that as well. Looking at all of those categorical column with the unknown values, P outcome has the most unknown, which is over 80%, and contact close to 30%, and unknown education and the job. So this gives us some idea, and we need to convert that to be the missing value to those unknown ones, and then it is important to do that so that an unknown is not misleading with our analysis. So here, just quickly, another categorical features versus target, looking at the subscription rate. So what we want to do is look at all categorical columns and check it out, group by the target where the target is yes, and look at all of those by each categorical column. I want to understand what are the features or what are the categories, values on those categorical column that have most yeses or customers with subscription rates. That's what we are trying to understand using the bar plot here as part of our visualization. So if you look at here, subscription rate by job, so basically students have most highest subscription rate, surprisingly. And here, retired, unemployment, management, bunch of those by the job. And the same information here on the percentage table as well. For the marital status, almost similar, but most singles have subscribed for the term deposit. And here also we have for the education. So tertiary education, or almost everywhere, tertiary education holders are the most subscribers. And we can also look at the default being no are the most subscribers, not surprisingly. And here also for the housing, customers' housing status being no have the most subscription and yes being just a few. And here we can also see most customers who do not have a loan have higher subscription comparing to having loan. Same way for the month, and this may not be huge valuable features to consider. March have most subscription, December and so on, and may not have the huge number of subscriptions, just a few of that. So looking at those features and success, P outcome, that gives us the highest subscription. Other failure unknown almost fall in the same level. We can also look at categorical features and the same information on the stacked bar chart. That will give us the better visual to understand on the same chart how much of the values we have yes, how much values we have for non-subscription. So we are filtering that when we have the subscription or target being yes, then we are marking that somehow to be in the different color comparing to non-subscribers. We want to plot that into the stacked bar chart. So kind equals bar, stacked equals true. That will add up to the 100%, and that will give us the better understanding by each categorical columns. We can have a very clear understanding that students having yes being the orange color, no being the blue color, most of those subscribers are the student. And likewise here, blue collar job holders, they have the least subscribers comparing to non-subscribers. Marital status, almost similar trend. Here education, almost similar trend, not huge difference. And here also we can look at the default. Those non-defaulters have the more subscription comparing to defaulters on some loans or some payments. And also housing, we have seen some difference. Also loan, we have seen some difference here. And the contact, we have seen some difference. But here the month has a huge difference. March had a high impact than December, then September. It's just what we have found in the data set. P outcome, the success, most subscribers, and rest 3 remain the same level. So quickly we can also understand the correlation analysis for the numerical features, how one column is correlated with another column in our numerical features. We are using the correlation matrix and we are plotting that value in the heat map. That will give us the solid understanding of if the two columns are highly or extremely low correlated than one another. So we can see that P days, it has a high correlation with the previous, but rest of those are almost unnoticeable relationship, mostly negative correlation, but those are not remarkable and making huge difference on those relationships. We can understand the data in depth by utilizing the EDA or Exploratory Data Analysis, and we can extract the meaningful insight from the data. What we have extracted is basically huge outliers in our data set that we have seen in the numerical features, and also the counts of those by the categories or by the labels, by the categories on each of those categorical columns, which we have seen a huge impactful information on our machine learning modeling. So this is the quick walkthrough on exploratory data analysis on our data set. And now next is going to be, we are going to do some data pre-processing and prepare the data for the machine learning, including feature engineering, outlier treatment, etc. in the next video. So thank you for watching this video until the last. If you need to go through those code and understand in detail, please feel free to pause the video, go through them in detail, and let me know in the comments what you think about those visuals. And also if you have any questions about the data set, we can definitely discuss into the next video, and please let me know in the comments. Thank you for watching the video until the last, and until the next video, please enjoy learning.